All right, are we going? Looks like it, right? Okay. Okay, so we need to finish up chapter 4. What is a price ceiling? Right. Maximum price. Who benefits from a price ceiling? Buyers, right. Please remember that buyers are who you are trying to help when you put a price ceiling up there. Does it really help the buyers? No. Not in the long run, right? Which is unfortunate because it's a good idea. It just maybe doesn't necessarily help all that much. It does tend to create a black market. Price ceilings make black markets, right? So what about price floors? Right.
Really nothing changed.
Yeah, essentially. I mean, if you think about it. So from the price floor, what's a price floor? Right. This is a minimum price. And who benefits from a price floor? Sellers, right? This is us trying to save the sellers. And again, what often happens when you put on a price floor? Again, it's a good idea. It does keep them open for a little bit longer, but usually what it's going to do is benefit the big seller just as much as the little seller. And then what's the big seller going to do to the little seller? Yeah. Very similar, right? Okay, so these are ways that we try and force price and quantity to not be at equilibrium, right? This is government stepping in and saying, equilibrium, bad, we don't like it, right? It's going to cause a consequence that we don't like, we try to stop it, okay? So, the opposite side of that is when it happens naturally. In other words, there are times when supply and demand will not go towards equilibrium. What economists will say then is that that was when the market failed, or there was market failure, right? So the definition of market failure is when the market price does not move towards equilibrium. So one way that that could happen is the government puts its hand in there and says, whoa, we're going to not let it do that, right? We're going to put in a ceiling or we're going to put in a floor to stop that from happening. Well, who else or how else could we have someone stepping in and saying, I'm not going to let price and quantity go to equilibrium? If the government doesn't do it, who else would want the price to be too high? Seller. So how would a seller make price too high?
Create a shortage or
So how do sellers do that, right?
it's like the one watch.
Well, I know, but all of their competition will release more, right? So
But there is no competition.
no competition. Bing, 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 bing. Exactly, right? So one way that we get market failure is lack of competition. But how could we, in this democratic country, right? I mean, it's democracy, right? Anything goes for the most part. How could we have a lack of competition in a market? We buy them out. How would that happen, right? You just have enough money to buy them out. That's absolutely right. So your name maybe is Bill Gates, and you walk in and you say, oh, you make computers, and you make computers, and you make computers? Nah, let's not. I'll just buy you, right? Because I got enough money to do it, right? Is democracy going to stop people from doing that? No, right? I mean, that's the whole point of democracy, is to allow you to use your money to do whatever you want. So in theory, this could happen, right? Of course, what happens, though, if companies do buy up all of their competition, there's only one seller in a market? What does the government do? creates antitrust laws, steps in and actually starts to regulate them whether they like it or not. Okay? So it doesn't even need to be a monopoly, folks. All it needs to do is have a lack of competition. So imagine, if you will, that you're a hospital, and there's maybe one other chain of hospitals in your area. What might those two hospitals decide to do? Yeah, why not? Right? They'd say, oh, well, normally we would charge, $150 for an MRI, but since we're the only two people who offer MRIs in this area, what might we do instead? Double the price and say, no, MRIs are going to cost $300, because what are you going to do with that extra $150? You're going to dance all the way to the bank. And that's kind of what hospitals do. Why? Because there is a lack of competition. Right? Because who's going to, how many other people are going to come in to, say, the Janesville area and build a hospital? Well, I mean, they shouldn't they? I mean, this is America. You could do it if you wanted to. Yeah. See? Right. But that was just another extension of an already existing hospital network, right? Right. So what were they trying to do? They were expanding, right, to guarantee their monopoly, right? I mean, St. Mary's was already here, right? So they were just saying, well, we're afraid that Janesville's gotten big enough that another company might come in and create a hospital and put it right here where people would like it. So instead they say, oh, we better build one here, and then they'll say, well, we need to better serve the community so that they can have a hospital wherever they need it, right? But what are they really doing, folks? Exactly. Now, that's a conspiracy theorist's opinion, right? That's not necessarily the truth, but sure seems like it might be, right? I mean, because when you have a lack of competition, what do? You're not going to charge the cheapest price. You set your own price, right? As long as people aren't, going broke, you're a happy hospital making lots and lots of money, okay? So lack of competition is one way that it happens. Now, and wait, well, before we go there, how do these people keep the price high? What do they do? I mean, what's happening when there is no competition? When there's nobody else competing? Which one of these things is being affected by a lack of competition? The number of sellers. And what are we doing when we're keeping sellers at a smaller number? We're keeping supply lower, right? I mean, that's what we're doing. We're restricting supply. And what does a restriction of supply do? It creates a shortage, and what always follows a shortage? Price hike. So lack of competition is basically saying keep supply away from where supply should be if we were at equilibrium. And so what happens to the price? It's naturally higher, right? And that's why healthcare costs are higher, right? Because there aren't enough hospitals to have any competition. And let's face it, folks, if you got sick or, you got in a car accident, a really bad one, are you going to ask the ambulance while it's driving you to the hospital to find the one that's cheapest? I mean, yeah. And are you going to pay whatever price they charge? Well, yeah, because death is the alternative, right? I mean, charging more as well. Exactly. Hence the entire process that's been going on in this country keeps getting bigger and bigger and bigger.
Second thing that occurs is advertising costs go down. So demand side that's another occurring event.
It's in there with it, certainly. Okay, so lack of competition, again, think of this as reducing supply, because you guys now know that a reduction in supply will lead to the price being above equilibrium. All right? Now, another reason that we can get a market failure is something that's called externalities. Now, what the heck is an externality? Something that's external, which is, kind of sort of semi-obvious, right? But it's a consequence of making / using a product. So a product is going to do something, which we know it's going to do, but it may have an unintended consequence that comes along with it. That would be what an externality is, okay? Now, this one, I'm just going to put it out to you right off the bat, right? There are two types of externalities that you can have. Exactly. You can have negative and you can have positive externalities. A negative externality would be producing electricity. We have electrical producing plants out there in our communities, right? Like Enron. So our, whatever the local, what is it, Wisconsin Power and Light here? Or Wisconsin Energies? Okay, We Energies. Okay, so We Energies, how do they make their electricity? Right, well, but what's the most common way, though? Burning coal. What happens when you burn coal, folks? You get pollution to go with it, right? So that pollution that comes from burning coal to produce electricity, that's an externality. It's a negative externality because do we really want to breathe pollution? It would be nice if we didn't have to, right? So what did the U.S. government do to try and stop this negative externality from happening? One, trying to make alternative sources of energy, and then what did they make those coal-burning power plants do? They made pollution laws. They forced them to only allow a certain amount of, carcinogenic particles into the air. They had to put scrubbers on all of their smokestacks so that as the carbon that released from burning coal goes into the air, they have to scrub some of it out and dispose of it properly, right? Now, what happens to a power plant when it has to put a scrubber on there? Do they just sort of make one? Costs more money to produce electricity. It's like a tax, right? Except that this tax is something that actually we would really want them to charge, right? Because otherwise our air would be very similar to the way the air was in Beijing in China. Right? You guys watched the Olympics last year? You couldn't see past 100 feet in China because there was so much pollution in the air. Because what do they do to the plants in China? Do they think they let them do whatever they want? They don't care. And they say, well, if you're going to produce electricity in China, great, make it as cheap as you can. We don't care about the consequences. Some people may think that. Yeah, it's true. All right, so the whole point here is that the negative consequence must be paid for. Right? And it can be paid for in either way in this country. You can either pay a tax or pay a fine for not cleaning your pollution. That's one way of doing it. The other way to do it is to actually make sure that the bad things that you are creating when you burn coal are scrubbed out of the air before you release it, right? Either way, though, you have to pay for it, right? So this is kind of like a tax. And what does a tax do? Again, put it in terms of supply and demand. It decreases supply. And what happens to the price of our electricity? Goes up. Reduces supply, and price goes up. So if you ever complain about electrical prices, remember what you could always get instead. Lung cancer. Take your pick. Because right, we could make this a free economic society where the government quits putting its hand into business, and we could say, well, okay, these power plants that are out there, They don't have to stop polluting. They can just pollute as much as they want, right? And you'll be able to go out into the Janesville River whenever you want, light a match, throw it on the river, and roast marshmallows over the river. It's also when you have, waste, say, in West Virginia. Did you guys hear about this one, right? The whole water supply in West Virginia was so bad that the government released a warning telling people that they shouldn't drink the water. I mean, the entire city, just Charleston, which is pretty close to the whole state of West Virginia. It was 80% of their population couldn't drink their water. Why? Because someone wasn't taking care of their negative consequence. So, again, it makes prices higher. It keeps us away from equilibrium, where the price would be lower, but we're kind of like, oh, that's not so bad, right? We don't mind it. Now, what's a positive externality? What is something that if you use it, it's actually good for society?
More than one use?
Recycling to some degree, right? That's not necessarily a bad idea. So recycling is something that would have a positive effect. Let's try and think of a product that we buy that has that kind of a benefit to it. I mean, you guys already mentioned them a little bit, right? What's the alternative to burning coal to make electricity? Wind or solar or geothermal or all these other methods of generating electricity. Why do we like those better? There's no pollution. Right, there's an externality. Now, the problem with it, though, is that it's more expensive. It's not as cheap as burning coal. Burning coal, folks, is cheap, right? You go get a rock, you throw it into a big, huge bin, and you light it on fire. That's cheap. Building those wind turbines, have you guys seen the trucks that transport the wind turbine pieces? I mean, they're huge, right? The blades are as long as, just practically this building. They're huge. Right? Do you think those are cheap to make? Do you think they're cheap to service? Do you think your electricity coming out of those is going to be cheap? No. It's not efficient on top of it, right? So what do we do for it? What do we do in order to make people use it? Tell them it's better for the environment. So electricity coming from, it's here, a positive consequence means it helps society when we use it. Now, the problem with electricity is that when we use this electricity, are we really helping the environment? Not really, okay? So from a positive externality consequence, it's not really one of the best examples, but it serves the purpose to some degree. A better example is probably more along the lines of getting vaccinations, right? Think about vaccinations for like the mumps and whooping cough and all of these other diseases that don't exist in our country anymore. Yeah, there's some issues with that. But the fact remains, though, is that if you get vaccinated for the whooping cough, you're not going to get it. If your neighbor isn't, they might get it. And what happens when they get it? Spreads. Even though you have the inoculation, you get it anyways, right? It's just preventing you from catching it. But if there's enough of the actual disease floating around in your neighborhood, folks, you get it. So do you want your neighbors to get vaccinated for whooping cough and bubonic plague? Hell yes, you will. Will you pay a little bit more for it so that all of your neighbors will get it no matter what? Yeah. Yes. Okay? So what you want is you want to force more people to want this. If you're trying to advertise to people that they need this, what are you doing? You're raising the demand. What happens when you raise demand? Here's supply, here's demand. When you shift demand to the right, what happens? Price goes up, and you pay more for it because of the positive externalities that it's creating. So a vaccination should only cost you about $5. But if you go to the clinic and get a vaccination, they'll charge you probably 15 or 20 if you have enough money to pay for it. But if you don't have enough money to pay for it, guess what they do? They comp you it. They give it to you for like $1, or they potentially even give it to you for free. And you're just subsidizing those other people, right? So the idea behind positive externalities is that you are forcing demand to be higher. And unfortunately, what comes from the demand being higher? Price goes up. Good or bad? I'm not trying to tell you it's good or bad. I'm just telling you the consequences, right? They're the same thing, except that one of them is reducing the supply and making the price go up. Again, if you don't reduce pollution, you're in trouble anyways. Here, you're trying to inflate the demand so that everybody has a vaccination so that you don't get a life-threatening disease. And the price goes up. What? This doesn't make sense, Mark.
You think, with a higher demand, it would cost more, yeah.
Yes.
But with a reduction in supply, you think that they would lower the price so that they would raise demands to get the higher price.
They don't need to. So when they reduce the supply, the whole point is to raise the price to cover those extra costs that they're incurring. And they're okay with selling less of it. That's fine.
So really it's win-win for the seller.
Oh, yeah. That's the way most of this world works. You should have learned that by now, Mark. Now you know.
Well, I do. Different, because of my age, I guess, I learned it a different way.
Potentially, yeah. But now I'm giving you the economist's way of describing it, right? I mean, you... Yes. Mm-hmm. All right, so what other types of goods have a similar existence where they're not going to be equilibrium? Public goods. Public goods also will not go towards their equilibrium price. Why? First off, what's a public good? Huh? What? City bus, yeah, City buses. What else? Library, sure, What else?
Not the tax government gives away like the dairy.
No, not that stuff. What do you drive on every day, folks? Roads. Who builds the roads, folks? City, right, I mean, all of that kind of stuff, all of the infrastructure that our country exists on, who pays for all that stuff? Yeah, well, I mean, we do indirectly, but we do it through our taxes, right? But all of those sorts of things where not one person buys it, but everybody uses it, right? So public goods, why wouldn't there be them in public goods? Who buys public goods?
There's no direct payback. Direct payback.
True, but who buys public goods? Do you guys buy city roads? No, who buys the roads? The city. Who else buys the roads? The state, maybe, but the state and the city are kind of the same person. It's just one's the right hand, one's... Yeah, they're all the right and the left hand of the same person. So who buys public goods? One entity. It's the same as a monopoly where there's only one seller, except now there's only one buyer. One buyer also leads to situations where you're not going to hit equilibrium, right? Because that one buyer isn't enough to drive enough competition, all right? So there are a lot of companies that make roads, but not enough of them as there really should be given the amount of roads that exist, okay? There's a good 3 or 4 different companies in the state of Wisconsin that make them. Of course, that was because we had a governor, Tommy Thompson, for how many years was he in? 16? And what was his brother best at? Building roads. He owned the biggest road production company in the state, and therefore everywhere in Wisconsin, the roads are paved, right? I mean, do you see any gravel roads in Wisconsin? I mean, you really got to think about it to find one. You got to search. If you go into Iowa and Minnesota, guess what? Every county road you drive on is friggin' gravel, folks. Why? Because their brother wasn't owner of a road paving company. Dirt roads, yeah, not even gravel. All right, so public goods are other reasons why, because there is only one buyer. Just like only one seller causing a problem, only one buyer causes a problem as well. All right, and those are our reasons for potentially not reaching equilibrium, okay? So normally, though, in any other circumstance, these things drive us towards equilibrium. I will, in general, give you products that moving supply and demand, equilibrium is going to be king, okay? But just realize that these are the sorts of things where it doesn't happen. All right. Well, let's not worry about income inequality. So skip that part of the book. Any questions about market failure? All right, that's chapter 4, folks. All right, so what I would like to do is give you a little bit of homework for chapter 4. So that I don't forget, because otherwise I will. What page is the 90? Okay. Please make sure you do the homework on page 90 because there is an appendix to chapter 4 which looks a little bit more about supply and demand, at least from the medical world. It's a nice appendix. If you've got some time, take a read. It's an additional introduction to the movement of supply and demand. But so what I want you to do is number 2 and 8 from chapter 4, but what I want you to also do is revisit number 6 in chapter 3. Number 6 back in chapter 3, remember I asked you to tell me what happened to supply or demand? Now, in chapter 4, I want you to tell me what happens to price and quantity because of that change in supply and demand. Do number 6 in chapter 3 and tell me what happens to price and quantity. So basically do that 4-question, problem for each of those questions in number 6, right? So if you said supply decreased, then tell me the next 3 things that are going to follow it, right? I would love it if you draw a graph, but you don't have to. Exactly. Yeah. So do the quiz for all of question number 6 back in chapter 3, okay? All right. Oh no. With 2 missed days this semester, we are way behind. There's no leaving early ever again, probably. All right, so we need to move ahead. So, chapter 5. Ooh, chapter 5 is we'll see what we think of it. All right. The title right off the bat should give you a little bit of the heebie-jeebies. Elasticity. Anytime you get a 5-syllable word, it's a great day. Elasticity. What does it mean to be elastic? Exactly. It's stretchy. If something is elastic, right, you can stretch it, okay? Now, what we'll do here is to look at the elasticity of demand. Now, you can look at the elasticity of other factors in economics. For this chapter, all we're going to worry about is demand, okay? So just bear with me with me on that particular incident, all right? The elasticity of demand, the definition of it is how responsive is quantity to a price change. That's the definition of price elasticity of demand. So in other words, if someone raises the price, how likely are you to buy less of that particular product, right? So if they raise the price by 10%, are you going to buy 10% less of that product, exactly the same amount? Are you going to buy 50% less? Or are you only going to say buy 1 or 2% less? All right? So please realize that I'm not breaking the law of demand. Whenever the price goes up, folks, we buy less. Period. Okay? This is even true of gasoline. When the price of gasoline goes up, you would want to, most people would probably say that we probably when you had nothing better to do, what might you do? Jump in the car, go for a ride. When gas is $3.50 a gallon, when you've got nothing better to do, amen. You're going to play video games, you're going to get out your phone, you're going to go for a walk, you're going to get your horse out and go for a ride. Because you're all owning horses, right? Right? And in addition, when gas is $3.50 a gallon, when you go to drive, you don't just do one thing with your trip anymore, right? I mean, when you're going to drop the kids off at soccer, when you're coming home, you're thinking, oh, I'm going to stop at the store on the way home so that I don't have to make 2 trips, right? I mean, all of these sorts of things are leading to you buying less gas. Now, not a lot less gas, but definitely less gas. So the law of demand still applies. It's just a matter of how much does it apply. That's what elasticity is talking about. So when the price of gas goes up by 10%, are we going to buy 10% less gas? Probably not, because we still have to get where we're going. But we will try and cut it a little bit. We will try and cut our gas consumption by like 1 or 2% so that we're not paying that huge 10% increase as much. Okay? Exactly. This is exactly why we are starting to see electric cars come around, right? Because the price of gas is so high. If the price of gas went back down to $1.50 a gallon, all those electric cars out there, yeah, see ya, right? I mean, the only people who buy them then will be those people who think that this whole carbon footprint stuff, right? Well, if I use less gas, then the earth won't hurt as much, and because the earth really feels our foot every time we step on it. Out of the billions of people. All right, exactly. Anyways, find elasticity. Now, economists who are slightly mathematical in nature, which is me, we want a formula. We want a formula and a number, because then we can say whether or not we're going to be elastic or we're going to be inelastic, right? Are we going to be stretchy or are we not going to be stretchy? All right? So, elasticity measured as a number. What's the first letter of elasticity? E. So guess what letter we're going to use to represent elasticity? Deep. All right, by definition, elasticity is measured as the percent change in quantity divided by the percent change in price. Yeah, it's right out of the book. Page 99. It's right out of there, folks. That's the way you do it, right? So mathematicians like to be fancy. We don't like these words. We like symbols. See elasticity written like this. They will say, ooh, when you write the word percent, what can you use as a symbol to represent a percent? The percent sign. Change, mathematicians, we use a triangle to represent change. The delta. It's actually a Greek delta for those of you who know some Greek. It's good for you, Greek. And here's Q for quantity, and then do the same thing for price. Right, so this is the mathematical way of writing elasticity, right? But it's the same thing. It's the percent change in quantity divided by the percent change in price. That's all there is to it. Nah, not really. But 2 of them, it makes it look good, right? Makes it that much more important. It means something, that's right. All right, so the key number for this, the key number, if I could spell number, for E is 1. That's the breaking point, okay? If the percentage change in quantity and the percentage change in price are the same, if you take something and divide by itself, what do you get? 1, right? 2 divided by 2 is 1, right? So if you have a 10% change divided by a 10% change, 1, okay? That's a very special case. We call it unitary elasticity because what's the value? What's another way of saying 1? Unit, right? If you have a unit, it's like having 1 of something. So unitary elasticity means that we have an exact equal percent change in quantity and price. Okay. So on gas, do you think that our elasticity, price elasticity, is unitary? Nowhere even frickin' near, okay?
Well, it is unitary,
Not really. It just means that it's not, it doesn't have any special elasticity. That's all it means. Equilibrium is outside of the case in this particular example, all right? So, if you're not 1, what are the 2 ways that you can go? Above or below. Okay. So the other 2 cases we have is where E is greater than 1 or E is less than 1. And these are the only cases you have to worry about. All right? Now, E is greater than 1. If E is greater than 1, then the percentage change in quantity has to be more than the percentage change in price. Right? So in other words, when the price goes up 5%, you are going to buy more than 5% less, right? Is that the way gas is? No, definitely not. What types of goods are there where when the price goes up, you buy a lot less of it? Can you think of any goods like that? Food, right? I mean, if you think about, say, steak. If steak prices go up by 10%, are you going to buy more steak? You're going to buy less steak. Are you going to buy a lot less steak? Yeah, because what are you going to buy instead? Chicken, burgers, you're going to buy fish. There's lots of other different things to choose from, all right? It's meat, right? Maybe you're going to buy more tofu. I mean, come on, right? I mean, something that has a lot of substitutes is the sort of thing where when the price changes, the quantity changes more. Those are the sorts of things that are elastic, right? Because when a price changes, you get a really pow hit on the quantity, right? This is a classic fast food example, right? When McDonald's raises its prices by 20-25%, what do? Hello, Burger King, Wendy's, Culver's, Carl's Jr.'s, the local hamburger shop that you have no idea what they're making, but it's still a burger, right? I mean, there's lots of other choices, right? So when E is greater than 1, we are elastic because a price change makes a bigger quantity change. And these are things that normally have substitutes, right? When their prices go up, we say, yeah, screw you, and we go buy something else instead, right? Things that are inelastic, that are less than 1, when there's a price change, you're going to buy less, but your percentage is not going to be as high, right? And those are the things like gas, right? If gas, are we going to cut our consumption by 50%? No. We wish we could, but we can't, okay? So here, this is known as inelastic because a price change only makes a small change in quantity. All right, so ease. All right, now the bigger problem comes from how do we calculate these percentage changes? Well, yeah, exactly. What I should have indicated that I would like you to do is not use the traditional percent change problem or formula. Instead, use what's known as the average percent change formula. What does that mean? All right, so you probably have seen this, or you see it in the book, right? It looks like this: Q2 minus Q1, Q2 plus Q1, and then they have P2 minus P1 over P2 plus P1. Whoa. It's math. What the hell is that thing trying to tell us? All right? These are just a formula. You plug the numbers in and make it happen, okay? Now, where do these numbers come from? Well, they come from the demand schedule. So I'm going to pick sort of simple numbers to begin with so that our calculations are not nasty. But this is a fraction over a fraction, folks. That means it's nasty. But you guys can handle it, all right? It's a little bit of math. It's not too nasty. I'm going to ask you to do this on the homework. Please note that I will never ask you to do this on a quiz or a test, okay? What I'm going to show you after we go through this once is the easier way to calculate this stuff, okay? But you do need to do this once because a little bit of pain, you know, that during homework is okay, so that you don't have to do it during a test, right? So bear with me. I know I don't want to make this class a math class, but you got to do a little bit of math in order to see what's going on. All right, so let's make up something that we're buying. Let's suppose that at $1 we buy 5 of these things. When we raise it to $2, we only buy 4 of them. When we raise it to $3, we only buy 2 of them. And if we raise it to $4, we only buy 1 of them. Okay, so this is, I don't even know what this is, but let's just imagine if at these prices, this is what we would buy. Widgets, exactly. It's some made-up baloney product. Now, what I want, or what you need to be able to do, is tell me, between each set of prices, what is my elasticity? It can change from price to price, as you will see very soon. All right? So, between 1 and 2, between $1 and $2, please note that you do not have elasticity defined at one price, okay? You only have price elasticity defined between 2 prices, okay? That's so right off the bat, please don't tell me that at $1 the elasticity is blah. You'd have to know calculus to do that, and I'm not going to make you do calculus because I'm a nice guy. But between 2 prices, you should be able to do this, all right? Please note that the little 2, that just means that you have to pick which row is 1 and which row is 2, all right? So call this row 1, call this row 2. And now just plug the numbers in to the formula. What is the quantity in row 2? So go to quantity, row 2, 4. So E is equal to. So first up here we put a 4. And then we're going to subtract the quantity in row 1, 5. You can. It's -1, and unfortunately what I'm going to have to tell you right off the bat is that economists are really bad mathematicians, and whenever you subtract a number and get a negative here, just throw it away. And I know it makes me want to barf too, but since we're in economics, you don't have to do math, so 4 minus 5 in economics is just 1, not -1. Again, this is why I don't like it. Because the math should be -1. Okay, anyways. Now, go to the quantity in row 2. What's the quantity in row 2?
4.
Still 4.
Well, change your rows.
True. But you'll see that no matter which way you change your rows, you're always going to wind up with one negative number, period. Because now when we do prices, we're going to get a positive one. But if we switch the rows, the prices are negative. All right, so now do the same thing, except use the price. What's the price in the second row? What's the price in the first row? 1. And then underneath it, add them. All right, so, oh boy. 4 minus 5, according to an economist, is 1. 4 plus 5? 9. Great. 1/9. 2 minus 1? 1. 2 plus 1? 3. Now, if you got out your calculators, you should be able to punch in 1/9 divided by 1/3. It's something you can do. Your calculator should have that power. What your calculator will tell you is that this is just 1/3. This is our value of E. It's 1/3. So, am I? Which one am I? Less than 1? Inelastic. Great. So this is inelastic. All right, so that's between 1 and 2. Guess what I'm going to do next? 2 and 3. So this is I'm asking you to do this once on homework for chapter 5 when you get it. So change what row 1 and row 2 are to the next 2 rows. Please don't, again, this is one of those things that students get a little bit confused about, right? Is that I can find the elasticity between 1 and 2 and the elasticity between 2 and 3. What I've seen students do is that they go, oh, between 1 and 2 and 3 and 4, so that they don't reuse a number. You can reuse a number, okay? So, let's find our elasticity between 2 and 3 using our same formulas. Well, we can do it here. Okay, so again, the formula is the same. What's the quantity in row 2? Please note we've redefined row 2. 2. And then what do I do with the numbers in the bottom half? What's my price in row 2? Over. And now do your math, and again, do it the economics way. What's 2 minus 4? Yeah. 2 over 6. 1 over 5. And I will do the math here for you. This is 5/3. Your calculator will probably tell you 1.6666666666666666666666666666666666667. Is this number less than 1, more than 1, or equal to 1?
More than 1, so it's elastic.
Note that between 2 and 3, our elasticity switched to being elastic. We'll get to what they want to do in a second. All right, so one more time, just so that we've done each row for our examples. A little math is good for you folks, I swear to God. I know you don't believe me, but it's good for you. Let's try it one more time. Between 3 and 4, again, change which one is row. And tell you what, let's do it. Let's this time switch which one we call row 1 and row 2. Does it make a difference? No, it shouldn't, and it doesn't. Exactly. It's economist math, right? So, Though if you define this as row 2, what's my quantity in row 2 this time? 2. Quantity in row 1? 1. What do I do with those numbers? Add them. Now do the price. The price in row 2 is 3. See what I mean? If you do it the other direction, then your prices wind up negative. So you always have to do economics math whether you like it or not. It only makes me kind of want to gouge my eye out. But 3 plus 4. Again, 2 minus 1. 1 over 3. 1 over 7. This is 7/3. Is that more than 1 or less than 1 or equal to 1? More, so what am I going to say my elasticity is between 3 and 4? Still elastic, okay? Okay, so again, I am going to ask you to do something similar once on the homework, just so that you can do it. If you need to get some math help, please go find the learning lab. They will teach you how to divide fractions if you have forgotten. It's good for you. Okay? Now, before you go, I want to show you the way to do this easier. Okay? The real way that I want you to do this on quizzes and tests, because the way I'm going to do it on quizzes or tests is I'm going to give you a demand schedule, and then I'm going to ask you, tell me, am I elastic, inelastic, or unitary between these two prices? And there is an easy way to do it. Okay? Only in economics, Mark. Only in economics. All right, so let's get another price and quantity here. And let's make it similar to this one to start with, okay? So let's suppose it was $1 and 5, $2 and 4. But let's suppose that this time when we went up to $3, we got to 3, and at $4, we only went down to 2. Okay, so it's slightly different, but at least the first 2 rows are the same. So when I calculate the elasticity between these 2 rows, it had better be inelastic, right? Now, the way you figure this out is that you make a new column. When you buy something for $1 and you buy 5 of them, how much money do you spend? If you buy something for $2 and you buy 4 of them, how much do you spend? 8. $3, 3. $4, 2. Okay. What this is known as total revenue. Because one of the things that businesses care about is how much money they collect. Okay? Businesses are always trying to maximize how much money they make. Now, revenue is at least one piece of that formula, right? What's the other piece of profit? It's revenue and cost, okay? So please realize that we're doing revenue right here. The reason we're talking about elasticity is we're analyzing the revenue that businesses make. This is the sort of analysis they do to figure out what price to set things at, okay? So, if they set the price at $1, they'll make $5. If they set the price at $2, they'll make $8. If they set the price at $3, they'll make $9. If they set the price at $4, they'll make $8 again. So just from an analysis of total revenue, where do you think the price should be set if you were the business owner? $3, right? Because that's going to maximize your revenue. Now, we haven't talked about cost yet, so we're not sure that's right, but just from a quick analysis, that's the way it works. Now, elasticity from total revenue. So we have 3 different types of elasticity that we can have. we can have unitary elasticity. When you have an exact percentage change in price and an exact percentage change in quantity, so if you raise the price by 10% and the quantity goes down by 20%, what happens to your revenue? The amount of money you collected stays the same. Price change does not change total revenue. Exactly. The elasticity between $2 and $4 is unitary because they're going to make the same amount of money in both of those problems. Whenever the total revenue doesn't change, unitary. Now, elastic. Again, what does it mean to be elastic? Stretchy, right? When price goes up or down, total revenue will stretch the opposite direction. Total revenue goes down/up. In other words, they move in opposite directions. Whenever price and total revenue move in opposite directions, that is when our elasticity is elastic, because they're stretching apart, right? When the price goes up, total revenue will go down when you're elastic. When price goes down, total revenue will go up when you are elastic, because they always move in the opposite direction because they have to stretch apart from each other, okay? So that whole definition of elastic should give you the rule for when this happens, right? So if elastic means it stretches, guess what inelastic means? It doesn't stretch, right? Inelastic is sort of like, this table. When I pull this table, the whole table comes along for the ride. When I grab my underwear and I stretch it out, right, does the whole underwear come with me? No, it's elastic, so it stretches out, right? I mean, that's... Underwear is a great example to use as an elasticity measurer. But here, when price goes up or down, total revenue has to go the same way. Total revenue goes up, down. So here they're moving the same way. Here, up goes with down, down goes with up. So when my price went from $1 to $2, my price went up. My total revenue went up. I am inelastic. I didn't have to do any of this crap, right? None of it. On quizzes and tests, you can do this if it makes you happy. So if you like doing this kind of stuff, go right ahead. You don't have to, though. This works just as well. Between $2 and $3, what happened to the price? It went up. What happened to total revenue here? It went up. What are we here? We're still inelastic, right? Last time the price went up, what happened to total revenue? It went down. When these two things are opposite, it's now regularly elastic, okay? We will come back next week and re-review this technique. This technique, this is the only time you're going to see it, okay? If at all possible. But realize that from Chapter 5, I will ask you to do one homework assignment where you do this, okay? Carissa? Thanks.